Start off as usual with a thumbs up for everyone who can see the future of IT trends. Here we got fastest fingers from Luca, Alan, Marcos, Mardy, Paul Bird. Yeah, Precious, Ronald. Okay, we're all ready to go. Fintan, Zachariah. Okay then. Today's session, we don't have any Kahoot. Oh, we don't have any breakouts. A lot of this is simply going to be a chat about the future. We've got some lead topics we have in the slides, and we'll kind of kick through those. But it's really an experience. It's really to chat about where we're going to go and what we expect to see in the future, because of course no one can predict the future. We don't have a magic crystal ball anywhere, but we've got ideas about what's happening, don't we? So I guess we're basically going to have a chat about the technology trends and where we're going in terms of what we currently believe is going to happen. Data center technology, we know, is a big thing. That's been around for a while now, hasn't it, though? So maybe a bit of a recap on some of that stuff. Trends in IT, AI, machine learning, large language models, etc., edge computing, and other things like that. We'll try and cover a few of those topics, but we also cover a few other bits and pieces. So feel free to pull things out. We can obviously spitball and chat about things as we go along. So, introduction to some emerging technologies. We know IT is one of those rapid industries. I mean, if you look at what we basically had, we look at what we had 10, 20 years ago, we had massive clunky machines running on 3.5-inch floppy disk drives, to where we are now, where we've got a massive compute on our wrist and on our phone. We know it's an exciting industry to be in. There is always going to be change in this industry. So there's always going to be things, and it's going to be driven by innovations, essentially, uncertainties, and certainly disruptions. The whole reason we've got such great Zoom capabilities and remote working capabilities at the moment is because we had that unfortunate thing, COVID-19 popped. And then all of a sudden, loads of companies went, oh my God, we've got to do things remotely. So all companies bought into that, and that massively accelerated the progress of remote working. And there's going to be a lot of impact on things like the economic, the social, and the environmental sustainability. I know I love working from home, but that's just me, isn't it? So some of you are obviously going into the office at the moment. If you do get a job in IT, then potentially that may not be the case. You may get the flexibility to work from wherever you like. And I think I mentioned before, I've worked for companies that have remote workers that are basically, that are literally placed around the world. I mean, we used to work with a guy in New Zealand and a guy in Australia doing web content delivery. We didn't care where he was because the connectivity was great. And as the connectivity expands, that then expands our innovations and our ability to create things. And as I said, it accelerates our technology, artificial intelligence, machine learning, VR. I mean, we've all probably played with a virtual reality headset at some point. I hope we have. Augmented reality. We saw the stuff on TeamViewer, didn't we? I showed you that beautiful video of someone wearing the Google glasses with TeamViewer and being able to see and visualize things in a virtual way instead of basically having to, refer back to a screen all the time to look at something. And you can project it onto essentially the display that you're looking up in terms of your heads-up display, isn't it? So we're going to quantum computing thoughts in there as well. Gosh, please, I will try and have a chat about quantum computing sometime today, and we will have a little thing because it's quite exciting, and it's certainly going to be something that's going to be, future tech around the corner. And then biotechnology as well. So biotechnology is basically in there. We are working on more and more techs in terms of our challenges. AR, what's the difference between VR and AR? Marcus, I love this. Let's dive straight into some questions. So VR essentially is a virtual reality environment where you are placed into a pretend environment. AR is augmented. So there's an additional piece on the side that handles things. That's probably the easiest definition I could give you in there, Marcos. Augmented reality is where you add something. So VR, you put on a headset and you pretend to be in that environment, and that's literally what you're in. AR is where you put on a headset and you'll still see the surroundings, and someone might be drawing on essentially what you are looking at in your HUD, your heads-up display. Remember that Top Gun fighter plane? Oh, with all the heads-up display stuff. So someone's basically drawing on that to help you. So I might look at a piece of machinery, and someone who's miles away, who's connected through to me, might go, that's the red cable you want, and they'll ring the red cable that I then need to move around. So that's augmented reality rather than diving into and being totally immersed in essentially a virtual reality. Does that kind of explain that, Marcos? That I think is probably one of the best definitions I've heard for it. Yeah, pretty much. That's cool. Cybersecurity is going to be important. We know our data. How many times in this lecture? I can't bet no one can guess how many times in these lectures I've said data is key. You know, look after your data, protect it. Cybersecurity, data protection, all that sort of stuff is going to be great. And indeed, this is where we kind of talk a little bit. We could bring out towards some quantum computing and threats of the future, but we know AI is already having an effect on these things, isn't it? So, you know, we'll go into some chats about that as well. So cybersecurity data protection is always going to be front of the queue when we start talking about the importance of future techs and relevance. Cloud computing and edge computing. We'll have a little chat about some of those as well. Has anyone ever heard the term edge computing before? Hand up if you've heard of edge computing. One was a no. Okay, well, perhaps we should go through a bit of that. I don't know if I should do it now. We might do it later. Yes, but I don't know what it means. Okay. Tell you what, we're pretty good at these sort of things. Should we dive? Same, crikey. Okay. Let's hold it for now. Let's click through a few slides because I want to make sure I get through the slides before I start going off on tangents all over the place. We will definitely bring up edge computing and exactly what it is, and we'll make things totally clear for you. So we can talk about IoT, Internet of Things, which is, of course, our beautiful watches, our fridges, our freezers, our kettles, and everything like that. It is the other things that are basically out there. Software development and DevOps is really going to be important, as is going to be things such as the artificial intelligence and machine learning. We'll dive into those as well. And I did mention the quantum computing earlier. So let's have a chat about a big clunky thing, data technology. We quite often nowadays use the term big data. Data has massively grown over the years. Okay, general data volumes, 2010, 2 zettabytes. Okay, and you can see just how rapidly it has grown over time. We don't expect that to slow down at all. We expect 2025, 181 zettabytes. For want of a better word, that's just a mass of things, but you can see it's constantly expanding. And what we call this is we call this big data. All companies now deal with big data because we like to get as much data as possible, because the more data we have, the more intelligence we can use for making decisions. And this is true for business. And this is also true for AI, machine learning, and large language models. The more we have, the more decisions and more things we can basically get out of it, which is why we store data. And now we keep data on absolutely everything. I mean, with the typical one is, yes, if you're on your browser and you're clicking through things, somewhere along the lines, that data that you're clicking through, you know, which websites you visited, what you liked, what you didn't like, what you watched and particular things, YouTube, for example, what you watched on YouTube, will get recorded somewhere. Now, it's not always the right place. Most of the time it is. But all this data about everything will basically come in, as well as things such as temperature gauges. If you think about something like an oil rig, okay, there's lots of temperature gauges on an oil rig. There's lots of different machinery and diodes and other things that are collecting data, not just about the temperature, but about the gas content, about the flow rates. All this data is basically getting collected and stored. And we don't just throw it away, we use it. Okay, and we use it. And this is why big data is so important. So it is massively important. And of course, we need to store it somewhere. So we have data storage for this. Now, normally we have something called a distributed file system. We kind of covered a little bit about this when we talked about VMs. Distributed file system basically means you simply have a massive load of storage and you can distribute the file system across all that storage. It doesn't even have to be in the same building for distributed storage. It can basically fall across a separate load of clusters. So I may be running several different storage compartments, as in disk drives on essentially, and I'm going to call it a NAS for now, use that terminology, so network address storage space. And I may have 5, 6 of those across my company. They may be in different locations across my company. The distributed file system simply says, I don't actually care where I store this. I'm just going to take that whole volume and I'm going to treat it as one big volume. And I'm simply going to put things where they should be able to go to. And that means instead of having one and having to go, I need to stick it in the Z drive, it simply goes, I need to store this and I don't care where I store it. And we can basically do data storage across distributed systems. Now, with all this data, we need to process it. And why do we process it? We process it so we can make intelligent decisions. There are products out there like Apache Spark, SQL on Hadoop. I would pronounce that one slightly wrong. And NoSQL databases and things that are useful for analyzing all the data. And they can analyze that data to allow us to make smarter decisions. We all saw when we talked about data centers, we talked about how they can do all the monitoring and they can control all the temperatures and they control the server power, the amount of electricity that goes into each server. So they can monitor all that and the workload that's done on those servers and the state of those servers. But all that data is no good unless we analyze it. So we analyze it, we look at it, and we produce those nice, attractive wallboards. And that happens not just for data centers, that happens for sales environments. So Marks and Sparks, a common retail outlet will analyze all that data. They will look for trends. This is why they collect the data. We then analyze the data and then they make smart choices. It's coming towards the summer. All of a sudden, people are not buying woolly jumpers. They're buying shorts and t-shirts. So they can see that data trend happen. So next time it comes around, they know when that trend is going to happen. They can map that with the temperature that's basically happening in the UK or in that particular area. So they can simply follow the temperature next year and go, well, when the temperature went up to such and such an amount, we had this peak in people buying shorts and t-shirts. So they can match that next time, and matching that allows them to make intelligent decisions. It means they don't have 400 woolly jumpers set in a warehouse because all of a sudden the UK temperature has gone up. So it's all about analysing that data. Now, here's a good question. What's this? I'm not sure who's going to get this one right, but there's definitely a sweetie on the way. What's the difference between a SQL relational database and a NoSQL non-relational database? Or let's see if anyone can type that one into the answers. Bit of a mean question to start with, I think, but I'll give you a minute to think about it. If you don't know, that's fine. You can hold your hand up and I'll explain things. While they're doing that, Alan, IoT, Internet of Things. This is all about Internet of Things is literally about any device that connects to the internet. And we are talking things such as security cameras. We're talking watches. We're talking microphones. We're talking temperature sensors. We talk fridge. We talk machinery. So if you're in a machining lab, you will potentially have systems that are driven that are essentially IoT devices that are not what we term as our regular compute and storage devices. So it's not a computer, it's not a bit of storage, it's not a network, it's an IoT, the Internet of Things. It's something else that's connected via some manner, normally Wi-Fi or a LAN cable, and that literally falls IoT. So it's a massive bucket of everything else. I hope that answers that one, Alan. SQL has the tables which relate to each other. Yeah, that's a really good punt at that one, actually, Alan. I feel possibly I should read what Rick has put in. No, all tables are SQL database or Thursday. Okay. Oh, I think you did pretty well in there. Alan, yes. Okay, so SQL database will normally have a set of tables. That's a very simplistic way to look at things. And they will have individual items that will relate to each other. So for example, if I have a list of names and a list of addresses, the relation between those two tables is the name, because I know Peter lives at number 9. So that's a relation between those two databases. If that sounds good. And SQL is designed basically to draw that. So there's a programming language called SQL, which allows you to query that. NoSQL databases tend to be what I term as buckets. So they're used for graphics, for videos, for other imaging such as that, other things. that are simply just jumped in and they have no relation to each other. So I may have a picture of a cat and a picture of a dog, and the only relationship between those two is that they're actually pictures. So I've got no relational link between those in my database. So it's a no relational data, a non-relational database. Good stuff. Thank you, Alan, for putting your hand up there. That was really impressive. Data integration and extraction, transform, load. Crikey, these are long things we're using already so early in this particular class. This is stuff moving forwards, okay? There are tools such as Apache, NIF, and Talend, which helps basically ingest data from multiple sources. This is what we're talking about in terms of it goes to multiple sources, has a look at all the data, pulls in the stuff it wants, and then gives you something nice to manipulate. Essentially what I used to call data mining. So you can go out to multiple locations and simply pull that in and then basically hook it all together. We need big data technologies for that. Data visualization and business intelligence. We talked about that. That was the M&S people remembering that when it gets warm, they need to buy more t-shirts because that's what the data basically told them. And of course, the more information they have, the better it is. Machine learning and AI is taking up a mass of our data. Let's have a little chat about machine learning and AI while we're here then, because that could be quite interesting. Machine learning. Has anyone ever heard the term machine learning before? Let's have a show of hands on that. Alan, did I cover IoT enough for you? All birds heard of machine learning before. That is good. That is beautiful. Not sure if it did. Right. Not sure if it did. We will see what we can get in. Okay, so machine learning is okay. Think of yourself as a baby, as a child. What happens as a child? You basically look around at things. Things hit you, not necessarily balls unless you live in my house. You look at things with your eyes, you listen to things in your ears, you smell and you taste things. This is all input coming into your brain. All these things go into your brain as an input. Okay, there's masses, there's loads of them. But when you first see, for example, a ball, well, you don't know what a ball is. So you've got no idea what it is. Now, in theory, now we don't know this is how brain works, but I'm going to make a bit of an extrapolation just so we can learn about machine learning. What happens is that data that goes into a ball hits your nerve endings, goes into your brain, and sparks off lots of different paths in your brain. And when those paths match what you're then told, a ball, then your brain ticks the box and goes, oh, I know what a ball is now. So it's learnt that. You might show the ball 20, 30, 40, 50 times going ball, 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 ball. And when it finally gets to the point where it matches those with the word ball, that's when you've learnt what a ball is. Machine learning is pretty much the same as that. There is lots of different pathways, neural pathways essentially, within the system that learn what things are. So this is why we need loads of data, because what we do is we get shed loads of data and we throw it at a machine learning system. Now that machine learning system will then learn what is going on, and it will learn things, and it will learn to pick out things. And when you get it right, there's someone at the end goes, yeah, you're right. And it ticks the box and goes, yes, that's correct. And it learns, the more it gets right, then it gets more and more accurate in terms of what it's diagnosing. So does that make sense in terms of what machine learning is? Because I'm now going to give you an application for machine learning. Yeah, good. Okay, so machine learning. So, and this is where I'm potentially going to end up. I look at this. I'm going to dive into edge computing. We're going to go left field straight away. How fun is this going to be? Okay. Machine learning is used for creating intelligent things, and they create intelligent packages. So let's use this as an example. If I show a computer video footage of people walking around a shop, hundreds and thousands and millions of images of people walking around the shops, that computer, I can then basically help that computer pick out the people that are likely to do something nefarious, people that might steal something, okay, on that video footage, to the point where that machine will be able to look at a video of someone walking in and they'll go, this person potentially will steal something or will do something nefarious. Little red flag pops up. So that machine has learnt to pick out that. Now, I've had to feed it tons and tons of data to get to that stage. But once it's in that stage, essentially, it is a small program. You now have a small computer program, an AI program, that is capable of noticing via a video camera feed if someone walking into a shop is likely to do something wrong. So that's fantastic. So edge computing comes in here, because what we now do is we take that very small package and we put it on the edge. So we put it next to where the camera is. We'll install a very small server in the office where that camera is located, in that shop. And that very small server will have the feeds from 8 or 9 cameras. And it will simply sit there on its own, a tiny piece of packaging, tiny piece of software running in there, going, that guy, that person there, shouldn't pick up, that person there is likely to steal something from your shop. And then they can raise a red flag and that can go to security. So the edge part of that compute is the small server that sits on the edge, because it's on the edge, it's not in the middle. So it sits on the edge at the actual site to basically run that very small program that we've spent years, not necessarily years, but we've thrown shed loads of data with. So we've got a massive chunking thing that does all the hard work and learns and does the machine learning. And that gets us a tiny package that we can then install at the edge, and that is edge computing. Wow, was that a good explanation? Ronald's got that. If you don't understand, wave a hand, because I can probably describe it in a couple of different ways. Can't believe what am I? 25 minutes in, I've already dived into machine learning and AI and edge. It's one of the hot topics. It's what it's really about now. Paul Bird, do you want to hear that again? Okay, so the machine learning part is where we throw lots of data at a very big, high-powered, complex computer. And that does the learning to give us a small program. And that small program, it's only a small program, we've asked it to define, in this case, we've asked it to define somebody might steal from a shop and their behavior. So that gives us a small program, which is really easy to run. And that will be able to tell who's going to steal from the shop. So that small program that doesn't need a load of compute power, because we've done all the hard work, we install on a very small server in the shop, and we feed 5 to 8 cameras to it, and it monitors 5 to 8 cameras and will simply tell us when someone comes in that is likely to steal something. So the edge part is the very small server that lives in that shop, and that's the edge part of the compute. The edge part of AI. Was that better for you, Paul? I'm not sure if I talk too fast at times. I get so excited. You just talk fast on these things, don't you? No problems, Paul. Marvelous work. Okay, we know big data is important. We have data security and governance. It is essential. Oh, Ronald's had a good explanation there. Yeah, edge is closer to the source. Yes, because it's the source where the camera is, where it's getting its data. Cloud essentially is over the internet. Yes, cloud is on the internet. So all these machine learning stuff are basically run in big data centers, whether or not they're a private data center or a cloud-based data center. Data streaming, we know, is big business, isn't it? Big technology. We are now getting more and more data into these areas. There's a lot of cloud-based solutions for us as well. We know full well there's plenty of cloud people out there, aren't they? With the Microsoft offerings, the Google offerings, and they're all there basically for us to use. And of course the Amazon one. I shouldn't leave that one out, should I? And then we run into data warehousing, which is really about what we do with this data. We've got a load of data. We know some of it we're going to be using all the time. We know some of it we're not going to be using all the time, but we still want to see it. And some of it we're not going to use at all for a couple of years. So we have our different forms of data warehousing, don't we? We have our hot store, which is the stuff we're currently using, which is normally pretty expensive to run. This is our big business right in the data center. Then we have our warm store, which is kind of the medium stuff. That's on slower media, might be in a different data center. Okay, and that stuff we might access. We need to get it fairly quickly, but we don't need it all the time. And then we have our cold store, which essentially is the stuff that we know we've archived, we've packed it away in a box, we stuck it in our loft or attic, depending on which country you come from, and we're not going to access it. But we know it's there, so if you do need to access it, we can go up, we can dig it out of cold storage, we can load it back onto our hot store system, and then we can access it. So it's important that we think about data warehousing because it costs a lot of money to keep things on hot store in comparison to any cold storage. So new technologies basically kind of come in a variety of things. We know we store a lot more audio now because it's easy to store audio clippings. We know we have specific information from sensors. These are IoT devices, our Internet of Things devices. I mentioned things such as, I mean, there's a bonus if anyone can think of another form of a sensor. So we've got temperature, we've got speed, so we've got volume, direction, wind direction, we've got waterfall. What else can there be? Air pressure, altitude, longitude, latitude. It's a bonus if anyone can think of other things. But yes, there's loads of different sensors, and that might include things such as our cameras and other things in there. We mentioned things such as spatial location. Okay, I might have cheated. GPS. Okay, so we've all got GPS data in our phone, haven't we? So we all know where we've been and where we're going. That's the important thing, isn't it? Google, all these phones will basically have the ability to store where you've been. So it knows basically where you've been. It's really good, and I'll tell you why. Not always great. I'll tell you why. I managed to pick up a parking ticket once. I know, very naughty of me. Well, I pulled into the car park. I walked straight to the pay machine. I paid for it, put the ticket in the car, went off, had a day in town, came back, and there was a parking ticket on my thing. And I went, hold on, that can't be right. Something's got to have gone wrong. And the ticket said, oh, yeah, we've got full proof of you basically being, the guy stuck a ticket. The ticket machine is infallible. It won't be wrong at all. It knows exactly when you arrived. We have you arriving an hour before you actually did. And I picked up my phone and I went to a Google tracker and I basically went, look, I can show that an hour before I was actually in a pub up the road with my car. So I wasn't parked. In fact, I was in a totally different town. So I went, I couldn't have been there because the tracker says I wasn't there. This is my journey. This is where I went. This is me paying for the ticket. And as expected, they kind of dropped off that. But so it's good having that sort of things. But again, that data's stored somewhere, isn't it? We have some traditional solutions in database models. Yes, we're going to start breaking those. Why would we not start breaking those? And we know we have our beautiful social networking. We know 99% of people are unfortunately on social networking. Yes, and it's good. It gives us an outlet. All that data and stuff is stored in a variety of places. But these are new technologies, blogs and things like that is basically kicking in, isn't it? Oh, look at that. We jumped ahead to the AI and machine learning. That was good. So we said it needs a lot of data storage. So we're going to collect a lot of storage and we're going to need to process that data. So we need faster and faster computers nowadays. Bigger servers, bigger server estates. Nowadays, whenever you drop a piece of data into a database, into one of these systems, they are automatically tagged or labeled as something in preparation for basically analyzing it further on down. So it's a bit like annotations on systems. Someone drops you a letter, you might put a blue stamp on it if it's basically something for your bank. You might put a red stamp if it's something for your kids, an orange stamp if it's something about a bill or something like that. So essentially, all this stuff that's coming in is automatically being labeled. So the data labeling it at source. The data exploration and visualization is talking about our beautiful wallboards that we can have. More data, more wallboards. We talked about the machine learning, didn't we? We talked about it being able to work out something. Can anyone think of something they would like a machine to learn to do that they that they would think would run on an edge computing system? I can think of a lot of good examples. Feel free to type it into the chat if you can think of something you'd like a machine learning system to learn to do. Remember, it doesn't have to be a physical thing. A lot of these are basic interpretations. I know in the UK there was one to dream. I have enough trouble with my dreams as it is, Marty. Reverse engineering? Yeah, I guess we could reverse engineer some things, Marcos, couldn't we? Paul, careful. It's okay. As someone who was divorced a while ago, yeah, you're probably, in there, mate, with what we should have. Yes, all that sort of stuff. One thing that came out recently in the UK, which was fantastic, is the medical arena. Okay, we know full well NHS is pretty run down anyway, but it's all fun, isn't it? So in the medical arena, women have breast scans to detect cancer on them, don't they? And it normally takes, and normally if you get a doctor in front of a machine and you give them the printouts, give them the breast scans, they can probably do, I think they said each scan normally takes them about 5 minutes to look through because they detail it and they ring things they're concerned about. That takes them about 5 minutes. They did some machine learning and they've actually implemented machines looking at these breast scans and they're doing 60 a second. So they're whipping through these. So the faster we get ladies in to have their breast scans, the earlier we detect breast cancer because their success rate was a lot better than the actual doctors were. Now, that's no disrespect to the doctors because they do a load of other stuff, but they were able to pick out smaller anomalies in the breast tissues that allowed them to get treated for breast cancer earlier and therefore improving the survival rate. Wow, that's massive development of AI and machine learning. So these things are all basically going to come in the process. With the need basically to do more and more in terms of our machine learning, in terms of our processing power, in terms of what we need to do, we need to have what's known as distributed computing. Now, we all went through a little bit of a course about virtual machines, which we know is you take one piece of hardware and you run multiple virtual machines on that piece of hardware. Okay, that's great. What distributed computing does is it kind of flips it a little bit on its head. It kind of says, I've got this massive piece of machine learning that I want to do. I don't want to just run it on one piece of hardware. I want to run it on multiple pieces of hardware. So you can get server stacks, 5, 6 server stacks together, and you can simply go, I want you to teach that as one piece of compute, and it will be distributed computing. So when your application is full throttle, it's using all 6 of those machines to the full capacity. And you're going, that is distributed computing. And why is that important? Because it means we no longer have to think about building bigger and bigger machines. It's not quite like that. But it does mean that, of course, as it goes up and it goes down, you can then simply use those and you can use different varieties. So very much the similar as you do with virtual machines, you can simply dip in and use a particular pool and then dip out and stop using it. And that's pretty distributed computing. It handles large scale data, okay, which allows, again, for the distributed model for this training for our machine learning tools. Again, we mentioned data privacy and security. I'm going to mention it about 8 times, I think, in this lecture. Natural language processing. Right, here we go. Should we dive into some of that? We'll probably cover it in a minute, won't we? Natural language processing, or LLM as well. Okay, it's given several different names in there, actually, that's used. And this is basically computers learning to talk in the way that we talk. I'll try and cover that a little bit towards the end. I won't dive in straight away. So we spoke about machine learning earlier on. Now, how many of you have got an Alexa at home? Let's see how many of that's set off. or any other device? Let's have a show of hands for anyone who has one of these beautiful devices. Luca's a definite no, thanks. You staying away from it? Are you worried about them monitoring you? Marcos does. Paul's gone for the Google Hub. Yeah. Alan's a no. Exactly. Yeah, Luca's worried about it. There is, of course, all that worry about is it constantly listening? Is it recording my thoughts? Not so much my thoughts, my words, my actions, and sending it off to the FBI or some nefarious company that's then going to use it for everything. Marty says, I tried using Siri on my phone, but it does not seem intelligent. Laugh out loud. Or am I using it the wrong way? It's all about the questions you ask, and we'll go into some more about artificial intelligence in a little bit. But these devices have become much more popular. And why do we have them? We have them because we're lazy or because we want to save time. I know I use it literally to save time. Okay, I can create lists on there. I can do calendars. I can do alarms. You can even have conversations because you can do drop-ins and things. And you can ask some crazy questions from them, can't you? So we all know we can ask them to look up particular facts for us. Some of it was good. Trust me, if you were trying to do this 15 years ago, the responses were absolutely laughable. But we've moved forwards an awful lot in terms of what we're basically doing. So the voice activation is a lot better. It's no longer worried about accents so much. So you can get by without it. So, if you are trying it, please, bear with it. Sometimes it gets better, sometimes it doesn't. Sometimes it understands. I know mine keeps turning the lights off when I shouldn't do. Unless that's my kids messing me about. And who's run into a text-based chatbot before? Oh my God, aren't they fun? I say fun, sometimes they're frustrating, sometimes they're great. Stupid, annoying. Yeah, and they do it on the telephones as well, don't they? So not only are we handling things such as our text-based chatbots, which at times I find sometimes are pretty decent, and they're getting better and better because of our natural language progressions that we're doing. So we're starting to get better at understanding what we are actually saying, rather than anything else. So text bots, chats, and we do this over the telephone now. A lot of telephone companies, a lot of call centers will have you basically talk about things, won't it? It's why have you phoned us? I phoned because of my accounts. I'll put you through to accounts. So they do all that. And you will find in recruitment and other places like that and sales, they are automating those sales calls. So I had a phone call from something. What was it about? I'm sure it was about Windows or something. Someone, as in glass windows. Literally a telephone call, automated telephone call. First thing they said was, "Hi, my name's Lucy. I'm the artificial intelligent chatbot that's going to try and sell you some Windows." So they didn't get much of a response. But literally, they're managing all those particular calls. Are you interested in using Windows? Yes, no. If the answer yes, then they might transfer you through to a human that you then speak to. So they're getting rid of all that, pre-telephone call conversations by simply doing it with an automated system. To be honest with you, sometimes it's pretty good. Will it get brilliant? I can see it moving on. And this is all future stuff. It's going to happen. Lucas made a very valid point there. I feel like the computer that I'm teaching is not willing to pay a normal person for the task. There's always that, isn't it? So beware of those. But there are some pretty good ones out there and they are getting better. Personal digital assistant. Yes, as I say, I use my Alexa basically as a personal digital assistant. Helps me out with my program, prompts me in the morning. It reads me a little story in the morning, tells me the weather, tells me the news, tells me what I've got on during the day. Wow. Wow, if I'd have asked my wife to do that, I'd have been divorced about 5 years earlier. But you can see how it is easy. So AI chatbots are doing that. Virtual receptionists as well are coming in place. And it helps with productivity and task management because I get warnings now when I've got things such as calendar events, when my meetings are coming up. Alexa pops up and says, "Hi, Dave, in about half an hour, you're supposed to be chatting to a lovely bunch of people about CSS and the future of IT." So I get all these notifications. It makes my life easier. E-commerce and shopping is a horrible one. I don't like it. Some people do, and some people don't. You ever find that if you go on to a favorite store, Amazon and others out there, and you search for something, so you ever look, perhaps you're looking for candles, or perhaps you're looking for a new mug, don't quite choose something. The next set of adverts you will get on your phone, on Facebook, on WhatsApp, or whatever it is, are basically all related to that stuff. So that e-commerce is literally shopping. It's kind of helping you out. It's suggesting possibly you wanted this cup, Dave. I go, no, I don't want the cup anymore. So I find it a bit annoying. Some people love it because it kind of throws some ideas and gives them curveball ideas and ideas that they basically probably might not come up with themselves. It saves you looking for it. Someone's going to simply come and hand it to you. Imagine walking around a shop and picking up a t-shirt, coming back the next day, and one of the shop assistants wanders around, picks up 3 or 4 t-shirts, wanders over you two and says, "Oh, have you thought about trying these ones?" All of a sudden you'd be thinking, that's great customer service. They remembered me. They remembered I was looking for a t-shirt, and they brought me 3 typical suggestions. I'd be waving the flags going, look, great customer service here. If a chatbot does it, all of a sudden I'm going, get off, leave me alone. One of those options, isn't it? This is where some of the technology and the artificial intelligence is going to help us, or not, as the case may be. So AI is pretty much everywhere right now. I'm going to talk to you about some AI stuff that is amazing. Not amazing. Yeah. Yeah, let's talk to you about some AI stuff that is amazing. I'm going to have a quick sip first, though. Can anyone think of areas where AI might be helping us? I'm just going to click through a couple of these because there's home automations. While you think about these things, healthcare and wellness we already spoke to in terms of the breast scans, didn't we? I see lots of you typing. That's obviously a fun question to ask, isn't it? I find AI is pretty much the forefront of an awful lot of flag waving. If you're a manufacturing company or a software designer or something like that, about the last 2 years, if you could have used the words AI in one of your marketing presentations, people were going, yay, AI. They're there, they're getting there. It's pretty much everywhere. Right, okay, let's have a look. Because I was watching some reels the day on Instagram. I wanted to set some of my brothers and I saw the same profile. Yeah. Already sent button, like it's ready and suggested and waited for you. It helps. I like that, Lucas. Sorry. It's helping the new generation to finish high school and university easier than it was in our times. When I was young, well done, Luca, when I was young. But there's 2 points of that, isn't there? Okay, the kids, what a horrible word. The youth of today is potentially using AI to write their essays. They're using AI to produce their thesis and their stuff and do all their work for them. But on the flip side of that, the teachers are using AI to spot the kids using AI. So they go onto Google and they go, right, here's a phrase from it, here's a thing. Has this been plagiarized? And they simply throw it out to Google and Google goes, yeah, this section's taken from here, this section's taken from here. And the teacher simply goes, right, you failed. You basically plagiarized it. Strangely enough, I had a note from my school, well, my son's school, literally saying AI and homework. Yeah, discourage your child from using it. But that's an important thing to think about, isn't it? Okay, we are getting better at that. Things such as language translations. Now we all know potentially if we're using Zoom, Teams, and the other chat systems, I can actually give presentations in English and someone can turn on the audio flag that basically translate the whole lot into their language, Spanish, Italian, Taiwanese is on there, I believe, as well. And it will simply translate it as a script, everything I say down the side. It can take meeting notes through the whole lot, so virtual meeting assistants. Okay, and it also then means once it's taken those virtual meetings, it can give you a summary. So I had a 2-hour meeting with my manager. Must have been Friday morning of all days. to our meeting with him. Fantastic. We basically recorded the whole thing, got a massive transcript, chucked into ChatGPT and said, look, can you summarize this and give me some action points? 3 seconds later, I've got a nice condensed summary, action points for me, action points for him. That probably would have taken me 20 minutes at least. And the better thing is it's probably all spelt right, which is not what I do. So it's like that, isn't it? So you can make a massive difference. It can help you. Marcos basically points out AI can help you erase some unwanted stuff from photos. It's running in Zoom session we have, yes. Security authentication. Yes, AI is basically getting involved in our security protection. Okay, because it is important that we make sure our data is safe. Gosh, I've said it again. Because it can now pick out certain anomalies a lot quicker because there's a load of data. You remember we talked about the SOC, the Security Operations Center, where all the data basically from your estate, your door key passes, your entry access, your access to the servers, who logs onto what server, etc., gets thrown up into a SOC system, and there's hundreds and hundreds of bits of data in there. Now, for someone to leaf through that and check it all out, really impossible. AI can look through it and simply look for trends, and it can look for things, but AI does the step forwards. I mean, you can write a program that simply says, okay, if someone's attempted to log on more than 3 times, we're going to kick them off. Okay, that's great. That's fine. But what AI will look for is AI might look for trends that you don't know about. There may be a security issue trend of someone potentially trying to log on twice, giving it 10 minutes, trying to log on twice, giving it 10 minutes, trying to log on twice. And AI might pick that up and go, oh, hold on, there's something nefarious there. It's not kicked your original rule because that's 3 times for the log on. And this is where AI helps us become more and more secure. Marcus uses it a lot when it comes to photography. Yeah, it's fantastic, isn't it? I think I've already asked this one. Have you ever interacted with a chatbot, or AI bot, for what purpose? Let's have a show of hands. Did anyone, I've flavored that question, haven't I? Did anyone have a positive outcome when dealing with a chatbot? I'm going to put my hand up because I know I have. Lucas a few times, yeah. Alan's not sure. Mostly annoying. Paul Bird says, I have in the past. Sometimes, though, it's because I was referred to a human. Yeah. So we know our experiences are varied. 10 years ago, it was just an absolute nightmare to do it. In the modern chatbots we've got now, it's much more easy. It's much more beneficial because they are learning the language because we now have our large language models. Anyone got any nice questions they'd like to ask about AI and the future of AI before I go along to analytics and insights? I think my system's not telling me if anyone's typing. But onwards and upwards. Okay, analytics and insights. Yes, it's all about analyzing that data. I spoke to you about it before. Big data means we basically need to look at things. So we can do some descriptive analysis. Okay, that's fundamentally, it's a bit like a components of data analytics. It involves examining, summarizing data to gain a comprehensive understanding of what it basically is. So we're looking at the data and we're basically going, this is what that data is actually showing us. And the other form we have is predictive analysis. So predictive analysis is basically where you look at a set of data, you criticize it, you analyze it, you focus on a forecast for the future. So the weather people use essentially predictive analysis. They look at what the weather does, what it's been doing, and then they go, this is what's going to happen. So that's predictive analysis. And predictive analysis is the smart end of things, whereas descriptive analysis is just like this data set shows me it rained on Tuesday. Thanks for your time. Predictive analysis goes, it rained on Tuesday, but I can see a new frontal system is blowing through, so it's going to be clear on Sunday. So it kind of does that. So those are the two differences. And then there's prescriptive analysis. Okay, this is really the highest level of data analysis you'll come across. This is focusing on providing specific recommendations for actions or decisions based on predictive and descriptive analysis. So what this basically does is this takes a system that says, yeah, we've analyzed the weather on Tuesday. We think it's going to be all clear on Saturday and Sunday. And the predictive analysis goes and says, okay, I need to buy a set of shorts from M&S because it's going to be hot on Sunday. So it adds something. It basically says this is the recommendation to get the best results of things. So analyzing that data is really, really important. A lot of our data is already digitized. We went for a set of items. I used to work for Select Appointments. It was absolutely hilarious because there was some fantastic law that said because they employ temp people, they need to keep all the details of those temp people that they employed for 10 years. And the good old fashioned days, it used to come on a piece of paper. So they had literally 10 years of data in essentially another building. It's just as big as the building we were all working in. It was just a massive paper warehouse, essentially. You've seen those things, everyone's seen those spy movies where they have those rows and rows of boxes and shelves and someone winds a little wheel and a thing. It was like that, and I couldn't believe it. And the first thing I said to him was, I said, why don't you just digitize all that and we'll store it on a server in our server room? Okay, and the next question was, how are we going to do that? So data digitization is important. It does take a lot of time. It is very cost effective though when you do it properly. And we spoke when we spoke about our multi-use printers, we spoke about OCR. Remember OCR, optical character recognition? And those are the devices that will basically scan your piece of paper and convert it into essentially a Word document or a PDF. So you simply need massive scanners, you put loads in the top, tucks it all out the bottom and produces you hundreds and hundreds of different documents that then you automate and stick onto your database. But definitely a key aspect of that is getting that done. We need to know the data sources for those. The method of digitalization is normally OCR, so it's normally done via a scanner. And we need to know what format it comes out, because we need to control whether or not it is a digital document, so it's created in terms of Word or PDF, or whether or not it's a graphics. And we need to set the quality of that data, because there's no point scanning a picture at a low resolution and a text document at high resolution, because you don't need that, do you? And then it's just a case of keeping it on some accessible media such as a server or a stored drive, and preserving that data. Any questions about digitization? It's quite a fun, easy thing. We're going to skip a little bit of digitization, I think. I think probably what we want to do now then, I think we need to have a little bit of a breather and have a 10-minute break if we can. And then what we'll do is we'll dive into the rest of the text. I see that Luca has basically stuck something up there about blockchain. We will cover a little bit on blockchain later on in this lecture. So we will have a little glance through that. Well, then let's have a 10-minute comfort break. And I'll see you in a bit. Well, welcome back. I had you a chance to get a bit of a rest break, comfort break, apple or banana, whatever you fancy having. And you're ready and fresh to carry on this exciting piece in terms of the futures of AI. Future of IT? Probably a Freudian slip there, isn't it? So it's a thumbs up then for everyone who can basically see the key aspects there, which is data democratization. Marcus is in there. Barney, Paul Bird, Maximilian, Fintan, Ronald, good stuff. spent a little bit of time reading the article that Luca posted out. We might have a little glance at that later. Probably not straight away, but thank you very much for poking that in. So data, we know we've got lots of data now, and we know what to do with it. But data democratization, wouldn't it be really good if we could easily get our hands on the data that we needed to either do our job or make decisions or do things like that we needed to do? This is really where the democratization of data comes to play. So the real concept behind it is that in the old days, if you wanted a report run, you used to have to go to either IT or you go to your data analyst and you say, I want this report to show me all the shorts that are sold in December, January, and February, and then the cost implications of that and the cost implications of storing those jumpers instead of basically selling them. And you basically have to go to them with a request. And then a couple of days later, they pull their finger out and they then give you a report. And if they hadn't included it or hadn't included everything you wanted, you'd have to run it again. If you looked at the data and went, oh, that would be really interesting if I could actually see that by week rather than by month. Okay. Data democratization basically is opening up that data. Now, go careful in terms of what we say opening up when we talk about data. Yeah. We are not giving everyone carte blanche to look at everything that they do not have access to. What we are saying is through some really friendly user portals, people should be able to go onto the systems, excuse me, and request the data that they need and have a look at the data they need in the way they want it. So if they want it in a pie chart, a bar graph, or just simply a big Excel list, they should be able to simply go in to a user-friendly system and request that information. Yes, AI helps us do that, but there are also lots of tools out there that basically do help us do that as well. We need to make sure that when we do this, because we are throwing it open to everyone and giving it people access to everything, we need to make sure we've got good data governance and good integration in there. So we need to make sure that the right people are accessing the right data and not the wrong people accessing all the data. So again, security data is key, isn't it? And these are designed basically to be collaborative and sharing, so they can basically share them amongst each other. So not only do you get the data, you can then put it onto a wallboard that everyone can see that needs to see it. What will also help you do this is things such as data categorization and metadata, because we can put small flags into the data, which we call metadata, that might tag those as being particular items. And focus again on our data security. And this does massively improve our decision making, because it now means that the CTO doesn't have to come to me as an IT manager or as a data analyst and go, Dave, I need to burn up some of your time to get this report for me that I want to show the board next week. I can go, well, here's your tool, go and do it yourself. Okay, put in your proper language in there and it will run a lovely report for you. And if it's wrong, then come and chat to me about the language you've used. And it's very simple to do. So there's a lot of great tools out there that will let you do that. Now, one we all love, data monetization. Yes, data is king. Data is king because it is worth money. Okay, we can monetize data in terms of selling it, looking after it, storing it, and all those sort of things. It is considered a valuable commodity. Certainly there's a very poor example, but we use it in the white label dating industry, which essentially is dating websites. People will sell their list of users, their database of users, usernames, email addresses on either the proper market, if someone's ticked the wrong box and says, yes, you can sell my data, or on the black market. And that data will be monetized because they can sell that on for a lot of money to someone who might be setting up their own website. So it can be monetized in today's world. How you work out the valuation of it is it's just by the market share. It's what the market will basically bear in terms of what it is. But there is some obviously guidelines in that that you will find, and you need to make sure that it's licensed properly. Press the button too enthusiastically, didn't I? But you have to go careful with the licensing because you can license data for use in a particular aspect. So you can license data to be used once, or you can license data for someone basically to own, so you can sell it on to them. That license will then depend whether or not they can then sell that data on or not. If I press the button too quick, it'll crash on me again. Or you can have a subscription model. People such as the Met Office have a subscription model. You can buy a subscription to the Met Office. This is for businesses that deals with things like the cloud and the pollution layers, which tell factories when they can and cannot release particular toxins into our beautiful atmosphere. And they can sell that as a prescription. We're basically going to have it and we're going to charge you monthly for all this data. So there are different models in there. It allows us to produce things such as data-driven products. So a data-driven product is simply an organization that creates a product that is a bundle of data. The Met Office does it. It's our weather forecast. So we will sell our weather forecast to people like the shipping zones, big businesses, as I say, that are producing factories, even people, as I said, like M&S that are concerned about when they need to get their shorts and T-shirts in. So they can sell all that lot on, and they sell it as a package. So it's a bundled up product. All data we know can come from cross-industry, so we can have some cross-collaboration. Because if we buy data from elsewhere, we can then bundle that ourselves and then sell it on, as long as we've bought the right licensing for that. Anyone got any questions about data monetization or anything around the data end of things? Yeah, that's fantastic. Okay, that's nice. So we're going to drift into remote work and IT adaptations. We know, and I've already said, that basically COVID basically had a very large impact on the terms of where we work, in terms of our remote works, and in terms of the adaptation for things like virtual conferencing and other items like that. We also brought in a lot of cloud computing because, yeah, it's great. We can use cloud computing now. We run it from data centers. We have our virtual private networks. We talked about that in terms of two forms, didn't we? You have a virtual private network, which is the one we have personally, that allows me to connect to a different ISP supplier, and that essentially hides who I am and my data. But there's a virtual private network where, for example, I may connect from my office to my business, and that allows me to have a private tunnel, which is another virtual private networking system there. It allows us to do a massive amount of collaboration. Microsoft Teams is designed as a remote collaboration tool, for want of a better word, but this allows us to work wherever we like. And indeed, we can do things such as manage projects. I don't need to go into work to manage a project because we can share things and we can do everything remotely. And it does indeed, online learning and training does indeed allow me to stand here and try and pass on some educational points and tips for you people. It's important to keep it secure. Multi-factor authentication we talked about, didn't we? Video surveillance and remote monitoring. These are becoming keyer and keyer. This is new stuff that's going to come into IT, not so much new stuff, but it's going to get more and more complicated. We spoke about mobile device management. It couldn't have been much more than about 10 years ago. And if a company gave you a laptop and you lost it, oh my God, you're in so much trouble because the data on that laptop could have been stripped. I mean, how many people have we seen in the press that some MP has left their laptop on a train somewhere, and then some press guys basically stripped all the data off of it and then published loads of stuff he shouldn't have done. Now with mobile device management, and it's a click of a button and I can have that laptop wiped. So we do have more security, don't we? We do have more better data backups and recoveries because we're pushing things to the cloud nowadays, aren't we? So rapidly shifting on. Internet of Things. Now, who was it asked the questions about the Internet of Things? Here's a good definition for it. The Internet of Things, IoT, is a concept that refers to the interconnection of everyday physical objects. Like I said, our camera, our fridge, our cooker, kettles, sensors, and everything like that. It has the potential to simply transform things. Years ago, Internet of Things wasn't around because we didn't have the data connectivity now. 4G, 3G, 4G, 5G means I don't even need a Wi-Fi connector near it. I can simply wander around. I can put a 5G SIM in a device. I can stick it anywhere I fancy and it can send me data. These are fantastic for things like bird boxes. If you ever get an option for bird boxes, yeah, you simply plug in, if your garden's long enough and it won't reach the Wi-Fi, yeah, you can plug in a 5G SIM into a bird box camera and they can send you the data. So the Internet of Things, think of everything else. It's all the stuff out there that's interconnected in some form or another. It's useful for remote monitoring, very scalable, automatic controls, gates and things like that. If you've got a really long garden, now having a camera and a automatic gate release will let people into your garden. I don't have a really long garden. I just end up having to walk to the end. And I probably need the exercise. So the important concepts are really thinking about your data transmission. How are you transmitting the data to and from that device? How are you collecting it? What are you processing? So what are you doing with those video images? I know I can say straight away, I've got 5 video cameras around my house. Not because I'm monitoring my children or anything. I've got 2 for security. No, I've got 3 for security. One in my what I term as the man cave to keep my son out of it because he keeps going in there and stealing all the food he shouldn't be eating. And one at the front door, which is a Ring doorbell. Let's have a little poll then. In the live chat then, can you type the number of, well, probably should say, yeah, we'll do it. The number of cameras that you have, essentially IoT devices that you have in your property. Don't really have to answer. It's not a competition. 3 cameras. Paul Bird says he's got 3 cameras. He'd like more. I think it's all about the data, whether or not you want it. Yes. I mean, I know I installed one of my cameras simply because my son said he was going to have a little party, a few people around, and I wanted to keep an eye on him in the back garden. All pointing outside, yeah. That's really what we're concerned about, isn't it? So it helps with security, but we can use these things on things such as the data floors. So if we get, if we are working in a data center, there's potentially going to be cameras and IoT devices monitoring door openings and closing. Part of the security system, isn't it? You can see edge computing's in there as well. We talked about edge computing, that device that's basically sitting on the end, the little server that sits near my cameras that monitors things. Okay, we're going to shuffle on to global market intelligence. Okay, global market intelligence is really about analyzing, an advisory service that works for information technology and consumers of information technology. Okay, it basically means we can basically pull a global load of intelligence in to pick up things such as our market trend forecasts. So we can look at conducting research into asset growth and particular adoptions. And we can look at how many people are buying, more cameras. Are there more IoT devices out there? Generally, the answer is going to be yes, they are going to be growing and growing and growing, aren't they? So we can get industrial specific insights in terms of where people should probably be focusing their learning, focusing their growth. So it gives businesses an idea as to where they should be providing their technology. That allows us to form things such as user cases and best practices. And indeed, that IoT ecosystem will eventually will eventually push a value chain, which is great for businesses. My main concern about it, or the main thing I tend to use it for, is simply for security. So IoT is here to stay. I hope no one's worried about it. Oh, now I'm going to talk about edge compute. I knew I'd steal my thunder if I went in too early onto it. So edge computing is about distributed computing across the systems. This is where we talked about you take that very small, very light program, you stick it on a very light server, and you stick it in an office somewhere that's basically doing some work, or you stick it on an edge. When we talk about edge computing, some of these devices now, I know HP certainly do, a waterproof one that can essentially be installed anywhere you fancy. So if you're doing some data analytics, or you're looking at keeping a track of the number of peregrine falcons that happen to be flying around Snowdonia, yeah, sure, you can bang a server up there, you can bang a camera up there, you can do what you fancy, several things like that, and you can very simply monitor things from up there. It's not really a real practical application for it, but that's the sort of idea that you'll basically have with some edge computing. The whole point of it is the proximity to the data source. So it's where you're gathering your data. You can do your computing there. And why would we want to do our computing closer to the data source? Anyone got an idea? Fancy smashing that into the live chat? See if anyone's typing in there at the moment. Can't see if anyone's typing, so I'm going to read it out anyway to you. I'm going to tell you the answers anyway. So the main reason you want to do that computing near to the data source is because it's faster to do it there. If you imagine, going back to our camera images, if you imagine running 8 cameras, getting all that data for the 8 cameras, streaming it down a pipeline to a server that could be 200 miles away, basically having a look at that data, there's always a time lag. You've also got to have a massive internet connection pipe there to pump that data down, because it's video images with audio. So that's obviously quite chunky. If you do the computing at source, at the edge, it's much quicker because you're literally just analyzing the data there. And the only thing you send up is the red flags. You send a little bleep going, oh, red flag, or you send minor pieces of data. Much smaller pipeline, much more reactive, because you can make that decision with your AI there and then at the edge case. So you get faster results. So you get, as it says, latency reduction, bandwidth optimization, real-time processing. And of course, you get some increased data privacy and security and scalability. Now, one thing you will notice and think about, if I've actually plugged a server on the top of a mountain that's stuck in the middle of nowhere, what am I doing for security? Because, some hiker may just wander up and go, what's this strange box here, and pick it up. Okay, so there is obviously monitoring tools and things like that you need to put into place there. And you do need to consider the security aspect of it. But it's much better to do it basically at the edge. Do all the big thinking elsewhere and do the nice little computing stuff at the edge. So any questions about edge computing that anyone would like to ask? A little sip of my having tea today. Trying to give up coffee. Okay, blockchain and distributed ledger. Let's put up your hand if you've heard of blockchain. I know a lot of us probably have. And distributed ledgers. Luca, this is all you want to know about, isn't it, Luca? Blockchain and distributed ledgers. Okay, blockchain basically and distributed ledgers, they kind of fall in together. Okay, they're a related concept that gains significant attention in recent years because, yeah, it's where it's going. Okay, we basically want to have cryptography, we want our Bitcoin and stuff like that. So these technologies, they've evolved and expand into various industries. Okay, they offer secure, transparent, and decentralized record keeping. So this means that instead of your bank having to know how many Bitcoins you've got, you can hold that data because you've now got essentially the blockchain that contains the information about the currency, how much it is, when you got it, and is immutable. So it's basically a record. It's a way of monitoring things. It's a way of holding information. Let's break it down then. So blockchain normally consists of a hash. So it's a block hash that makes it an individual item. Okay, that is a unique hash. There is a previous hash because every time you change something in a blockchain, it gets a new hash, but it keeps a ledger of all the other hashes, the previous hashes. Then there's some smart contract, and then there's actually the transaction. So the smart contract is the piece of code that essentially defines the rules for the transaction. Okay, it defines how it interacts with the ledger, and it executes inside the blockchain. As I said, the hash is the unique identifier for that particular blockchain. The ledger itself is immutable. That means it's not destroyable. You cannot delete these things. You shouldn't delete. You can't delete these things. You can't remove them. So the smart contract is simply a piece of code with the rules of that particular transaction. Hash is unique, and the previous hash basically comes from the previous block identifier. So with the decentralization, this means, as I said, the bank doesn't keep the details, you hold the details. It's immutable, so each block is unique, and therefore it cannot be replaced and cannot be repeated. That's the important thing, is no one can repeat that particular blockchain because it's an individual hash that's basically used. Privacy is really important because privacy is key, so users remain hidden. So your identity is not basically stored within that blockchain. So regardless of whether or not it's in the public, private, or hybrid, that blockchain is basically secured. So what makes it more secure? They use this term CRUD. Okay, create, read, update, delete. Okay, that model is modified and the update and delete disappear. So no blockchain essentially can be updated or deleted. That means it's an immutable reference to your basically any particular cache or that particular data or anything that moves along. So rather than basically passing transactional data, we pass data that is now indestructible, for want of a better word. So part of the philosophy of the blockchain is the treatment and where it writes the ledger. So the ledger is distributed by blockchain design. Okay, when it's created, it is a centralized repository. Having a look there. Luke has basically put some stuff up there. It's a cold wallet. That's a good description, actually. I've not heard it described like that before. Well done. So because it's decentralized, that means it is your responsibility to keep it and look after it. Just seeing what people are typing in the chat. It's good work, people. Now, one of the classic examples of this and how much fun it can be, whoever heard of, it's not quite a famous guy, but I remember years ago when Bitcoin was first released, yes, when you traded in Bitcoin, you basically had essentially the blockchain details that basically passed you for the transactions. So on your computer, on your physical hard disk drive, you basically had the keys that simply said how much Bitcoin you actually owned and how much you were worth, etc., were stored decentralized, stored with you. One of the really early investors in BitChain had an old computer. He basically logged on years and years ago, got fed up with it, threw it into a tip. So chuck that out. And about 4 years later, he looked up how much his bitcoins would have been worth if he'd kept the computer. Quite happily, he would have been a millionaire. But because he didn't have that disk drive, he was unable to produce the blockchain and able to produce a proof of ownership for those bitcoins. So he was quite upset. I think it's probably the best way to look at it. So NFTs are struggling onto this. NFTs is a type of blockchain implementation. So this is really an implementation of it. So it's unique and do not change. Okay, it's non-fungible, non-changeable, essentially. Okay, it's a bit like a cryptocurrency. Okay, and you can see where it's basically being used. So these are not consumed. So they're non-fungible. They're associated with particular objects. So they can be sold or bought. Can't be divided. So they are for particular objects. So in the metaverse, potentially you could use it for metaverse objects such as paintings. Okay, so a painting might have an NFT basically associated with it, or a dress might have an NFT associated with it, and that allows you to sell that item essentially in the metaverse and transfer it across using blockchains in a non-fungible token. And therefore you own that, and therefore you can show that you own it. Bit interesting. And potentially what this leads to in the long run is a demonetization of everything. And that we will no longer be dealing with money. We will simply be dealing with Bitcoin. We might even drift away from Bitcoin back to essentially a bartering system. I don't think it will get that far. Grand. Okay, I've deliberately sped through some of those slides simply because they are very interesting. But what we like to do is at the end of this one, because it is the future of IT, we like to have a bit of a chat. So we kind of had an open chat forum about AI, large language models, machine learning. Precious wants to leave a bit early. Was it? There's the sun shining out there, Precious. We didn't go massively into quantum computing, which is definitely something that is just around the corner. No, Precious, it's time to learn. You're not allowed to leave, Precious. I'm only joking. It's your free time. So we've had a good chat about this. Anyone got any particular questions about what they see in the future before I start going on about quantum computing and what it means to us? Night shift a bit hectic, Precious. You may definitely go. You can always catch up with the recording, can't you, Precious, when I start talking about quantum computing at a later date. Thank you, Precious. Well, this is actually the last, well, as Precious is disappearing, this is my last lecture I'll be doing with you. I go on holiday for a bit, and that means I miss probably the goodbye piece. But you know, from my point of view, I'd like to say I've really enjoyed basically giving these lectures. The interactions we've had between us all has been stunning and great fun. I know, I know. Sorry, Paul. You know, and the Kahoot has been very interesting. You know, and all I can say is that, you know, I wish you all the best of luck in the future. Certainly from some of the questions and some of the interactions we've got, we can see that you are all very bright. You are all basically going to make it through. Do see if you can to get the CompTIA A+ exam under your belt. That will certainly give you a ticket into the IT industry. It's definitely worth doing it. Do pay attention to Ragib when he basically talks you through the exam preps, which you've got next week, haven't you, Ragib? And we'll definitely have some fun with that. So that's kind of my goodbye initially. I want to get that out of the way just while Precious is kind of here. Thank you, Precious. Well done, Precious. Plan on taking the exam. That's fantastic. I have more chance of winning than you, character. Luca, you will be fine, buddy. Paid attention to a lot of the stuff I've gone through. You'll be fine. Certain exams is always a bit scary, but these are sort of, yeah, they're okay exams. And we've given you the tools. We've covered all the topics. Some of the stuff we go into in a lot more detail than they need in CompTIA. But this is simply to give you a better background on it all. And I think it sets you in a better stead when you sit down in that interview, rather than just reading out the CompTIA exam questions. You can basically go and talk around the outside of things. So has anyone got any questions they'd like to ask? Or would you all like to, let's have this. Type a question in the chat window or put a thumbs up if you want me to talk about quantum computing and what it means to me. Marcus, I'm in for that. Says after we win the jackpot, we're going to gather in London for a few drinks. Sebastian's in. All right, are those thumbs up for quantum computing, I guess, isn't it? Right. Okay. Right, okay, let's run through some basics and do a comparison then. Everyone else who doesn't want to listen to quantum computing, I don't know if Russia wants to say goodbye or anything like that before I start talking a bit about quantum computing for 15 minutes. We've got time at the end, haven't we, for your bit? Let me see what I cover for quantum computing. Right, here we go then. So quantum computing. Our computers run on what? What do we basically have in our system at the moment? We have bits, don't we? And what are the state of bits? So what is a bit basically? Here's a good question for everyone in live chat. What are the values that my bit can be? It's a packet of data. Yep. 8 bits form a byte, don't they? Sebastian, packet of sweets coming your way. Can't run out of sweets now. Who am I going to give my sweets to? Definitely not my kids. Sebastian, 1 and 0. So our computers run on ones and zeros, don't they? Great work. So our computers run on ones and zeros. That means we can process a 1 or a 0 in each one of those slots, doesn't it? So that means over a certain amount of space, we've got 1 0 1 0 1 1 1 1 0 0. Okay, beautiful. The difference between that and quantum computing is we don't just have 1 and 0. We have 0 and 1 and everything between it. Okay, so we're no longer dealing with a 0 and a 1 each time we do a bit of processing. So we've got everything between it. So I like to think of it, and this is very poor, of being 0 0.1, 0 0.2, 0 0.3. It's a very poor analogy, but that's basically it. Now, is it 0 0.11, 0 0.112, 0 0.113, etc., etc., which means we can have a multitude of states for that particular item. So instead of just being a 1 or a 0 in that item, we now have a 0 and lots of different states all the way up to 1. So that is quantum thinking. Now, how we get to quantum and why it's called quantum. Who did chemistry at school? I did. Marcus, I might be leaning on you to help me out somewhere along these lines. Did you pay, more importantly, Marcos, did you pay attention when you did chemistry at school? Okay, so this is what it's all about then. Now I have got quantum computing. Okay, so we now know we've got let's do the first bit. Let me rewind a little bit. So now instead of doing a 0 or a 1, we've got a 0 or anything up to a 1. So straight away, when I'm processing that piece of data, if I can process that piece of data in the same speed I process a 0 or 1, wow, look at that. I've now got a very poor example, 256 times more processing power just by switching to a quantum computing. Yeah. Now, why is that important? That is important for 2 reasons. We can do shed loads more. We got more processing power. We can do things a lot quicker. Now, more processing power means we need to start getting a little bit more worried. We've got our general encryption ratio. This is where some of the business is getting a little bit scary. Our general encryption, 256-bit encryption. Now, I think there's some maths out there that said it would take one of our regular computers about 1,000 years to basically decrypt a 256-bit encryption. Okay, now imagine that I am doing 256 times as fast as that. So straight away, my quantum computing is looking like, hold on, 256-bit encryption. That's nothing. I'm going to go through that like a knife through butter. So that's why people are getting a little bit nervous about quantum computing, because it's a massive leap in terms of the performance and speed we can do, which then puts our encryption in danger of being cracked by someone who can afford a quantum computer, which potentially is the truth out there. Do we have to worry about it yet? No. No, we don't have to worry about it yet. Right, so how do we actually get to 256 or X number of different states for that one or that zero? And why the hell is it called quantum computing? Well, the key is it's nothing to do with James Bond. What it is to do with the quantum atom. So you know we have our beautiful atom. Look at that, straight out of chemistry, that is. Our beautiful atom. And round our atom, Marcos is going to confirm this, round our atom, we spin an electron. So an electron spins around our atom, doesn't it? Now, which way does our electron spin around the atom? No, I'm not going to put you all out of your misery. It can spin either way. There you go. So our electron can spin either way. Now that, of course, gives us a 1 or a 0. Wow, that's easy. But it doesn't just have to be 1 or 0, because it can be any state in between that 1 or 0. So that's where it becomes quantum computing, because now I can look at that atom and go, not only do I know which way it's spinning, but at any one point in time, I can tell where it is in terms of its spin. And that gives me shed loads of different positions. That's why I no longer have a 0 and a 1. I now have a 0 and everything up to a 1. So that is quantum stuff. Now, the fun part of that does mean, of course, we've got a lot more compute power. But is it just compute power that quantum physics is involved in? See, Marcus, it looks easy in theory. It looks easy in theory. I read a bit about a week ago, and I had to put the book down. It's just silly. I say book, of course, it was on the computer. So it was just entertaining, because what they're saying is that, of course, when they read, because they have to read it, when they read it, of course, it knocks it off site. So no longer would it be spinning. So they have to go, this is set to somewhere between 1 and 0. We're going to read it, and then we've got to reset it to what we read it at. So it's like you read, then you've got to reset, because as soon as you read it, you knock the electron out of its what you're supposed to be doing. And then you've got to put it back into it and then fix the state. It's called a fixed state quantum physics. Wow. Now, did that scare you enough? Now, what's going to even blow your mind even further than that, I think, blows my mind, certainly, is that they've actually worked out, part of quantum physics is they've worked out that atoms can be paired. Oh, this is why I wish I had a second one. Right. They worked out the molecules can actually be paired. So now what I've got 2 with my electron spinning around it. Yeah, it's very simple. It's spinning around it. So I've got 2, and they synchronize with each other. So these 2 atoms will have an electron spinning in the same direction. Fantastic, you think. What's that got to do with the T of China? The important thing is, if I take this atom and I put it 400 miles away, that molecule is still spinning the same way. Now, if they're paired, if I change the direction that this one is spinning, the direction on this one will change in the same way. Now, that's what I call magic, as Paul Danielson said. What that means is I can do quantum networking. So I can send a signal from this atom to this atom without any wires across space, not time, but across space, a long distance. They haven't done it over long distances yet. I think they've done it over about 10 meters. Over that distance, to simply pass a signal, a network signal across. And it's faster than the speed of light. Now that kind of blows my mind, because that means we can communicate pretty rapidly with absolutely anything. How close are we to get there? Don't know. I like to think the scientists will pull their finger out and get it sorted. Certainly before I shuffle off my mortal call, that would be fun to watch, wouldn't it? Wow. So who's still with me? Who's still with me after that lot? So that's what I've read at the moment. That's as far as I get with quantum computing. Yes, there are companies out there that believe they have produced a quantum processor. It's light years off being commercially viable. But I mean, we could have said the same thing. I mean, if you were, if you were back in the 40s, you were laughing at Babbage, weren't they? They were laughing at Babbage about some of his great ideas. Was it Babbage? Got the wrong name there, haven't I? Yeah, probably. But you can see that IT is not going to be that industry that is simply just going to go, oh, we're just going to, peter out and stop. It's going to be an industry that's going to carry on going up. It's not like cars. We've still got cars with four wheels, an engine. They've got electrics. Oh, that's an electric engine. That's great. But there hasn't been a leap in the way we do transportation in terms of cars, has there? But our computing stuff is still going absolutely crazy. And may it forever be so. Good, 10 minutes too. Has anyone got any fears about the future of IT? Anyone want to share something in chat? Definitely AI. AI is one of those things. And I know we set ourselves up. We set ourselves up by the fact we've all watched the Terminator films, haven't we? So we've all seen those. So straight away, we're thinking machine's going to take over the world. It's going to blow everything up. Okay. The important thing about AI, it's only it only does what we tell it to do. We still have all the control essentially over AI. Stop Skynet. Yes, exactly. I heard someone say in a lecture once, was it a TED talk? Can't remember which one it was. TED talk. Probably we'll call it a TED talk. I remember someone basically said, in TED talk, why is everyone afraid of losing their jobs to AI? Okay, AI won't replace you, won't replace your job. You won't lose a job to AI. What you'll lose your job to is someone else who can use AI better than you do. So be in front of the curve, pick up AI, learn to use AI brilliantly, and then you'll be first in that market. You won't be the guy who gets replaced by someone who knows to use AI better than you do. That's the way to look at it. Any questions from anyone?